Now let's move to the challenges, which is like really important. But let's say nowadays, if we go back years, there was nothing called smartphone, there was nothing called data. I don't even imagine that people were like thinking that at some point we'll be spending more time on our mobile phones than sitting like with someone personally and talking, or in a cafe or something. So nowadays, like it's integrated. So this data nowadays, like, and this traffic growth really affects like the network performance. So the traffic growth, it leads like to network performance issues, as well as it leads us to the need of the use of new spectrums, like because the current spectrums are not enough to use new ones, as well as the cost become higher and you have more security breaches, and as well as at the end it makes it very hard for the mobile phones manufacturer. They are really suffering nowadays when you want to like design a proper UE. So let's start with the traffic volume growth. Let's say with these millions of subscribers worldwide, even billions I'd say, and a variety of like new products like coming every day, traffic volume growth. First, let's talk about the operator side. It will increase the cost too much, like the operational support services, customer care. It's becoming more complex. So in order to, let's say, overcome this traffic growth, things are becoming even like more complex. And this is like increasing the financial overhead. And for sure, at the end, it will be increasing the prices sometimes on the consumers or on the customers, even though like the operators trying their best not to do it. As well as nowadays, like since last 4 years, 2016, 2015, you are like hearing smart homes, smart solutions like IoT, Internet of Things. And the Internet of Things actually will lead to an explosive growth in the connected device to the network. So this like growth will be generating, let's say, billions and trillions even of new data resources, because you can imagine like your refrigerator will be connected to an internet. Your oven will be connected to the internet. Your AC will be connected to the internet. So it's no longer only like mobile phone, iPads, laptop. Everything will be connected to the internet. Even the cars, like with the 5G standard V2X and V2B, the vehicles will be even have the ability to communicate with each other even. So this will be like generating, let's say, huge traffic on the network. And for sure, like everyone wants good performance and like good data rate. And sometimes it's out of, let's say, the operator hands. Like the performance falls off considerably, like worse, especially in complex indoor environment or crowded environment, like let's say stadium or something like that. And to provide, like let's say, many people in small places with very good data rates, it's really a challenge nowadays. And this will like introduce like a lot of problems here on the network performance issues. We'll be like having a lot of drops, we'll be having a lot of poor services. Now, a lot of solutions like built since many years, they started with something called indoor building solution, which we're like installing inside the stadiums, inside the malls, in order to help even like the outdoor units in performance inside the stadium. And nowadays, even like in 2019, Ericsson came with a new solution called radio stripes, which is quite complicated, but it's really nice. You can just, for example, like Google it later on, and you can just check about it. It's still like a new solution, and it tested in any place in the world as far as I know, actually. So now this like traffic and growth lead to a lot of performance issues, which make the 4G optimization engineers, or I would say for now 4G and 5G, terrible actually, in order to maintain the capacity and the coverage for the network, and in order to maintain customer satisfaction by providing them, let's say, good throughput. It's really becoming harder and harder every day. So one of the solutions which came with the 5G, actually for 4G as well, was the new use of new spectrums. Now with 5G, they came as well with the idea of using even more new spectrums, that we are like, instead of staying with the bands which is less than 2.5 or 3 gigahertz, let's go up. So initially they increased the bands up to, let's say, 7 gigahertz. They call it FR1 for 5G. Then they will go to millimeter wave bands, which was from, let's say, 28 gigahertz, 36, 34, 26, 24 gigahertz. Sure, like when you go upper end band, like things will be different than with like staying with the lower bands. as we know that, let's say we have as well Wi-Fi access points which use like 6 gigahertz and 5 gigahertz as well as 2.5, 2.4, but it's unlicensed band, which is totally different than 2G, 3G, 4G, 5G band, which usually a licensed band where the operator needs to pay money for the, let's say, in order to be able to use such frequency. Even like with all these, let's say, new standards and new ideas evolving, it's still like very hard to efficiently design radio systems that can, let's say, actually take all the advantages of all these new protocols. But you might come up with an idea. At the end, you will be having some hardware limitation that, okay, the idea is accepted by now, but still the hardware cannot support, let's say, or like such ideas and software. So it's quite, and hardware, so it will be quite difficult. So even now, they said like, let's come with a new spectrum. It was like really actually hard when you come like let's say for example, we imagine this, you have this mobile unit or a UE device, okay, and you just want to connect to a network. Let's say that you have this only one frequency. It will be easier to select than you will have many frequencies where the mobile needs to say calculate and see which one is the best one and connect to it. So it's like, this is for sure, this is like an optimization job as well in order to help, let's say, to reduce this timing in order to save the mobile battery when it's connected to the network. For sure, this like introduce a lot of problems. Let's say, if we, let's say that like, okay, we talk about some bands, for example, like you find some phones that it's working in Japan, but it doesn't work in US, it doesn't work in Saudi Arabia, it doesn't work in India. And the idea of it, like they will be supporting different bands. So sometimes in order like to make it easier for them, they just make it like to support this certain country bands in order to make it easier for them like on the design. Move to talk about let's say, for you like spend a lot of time on the spectrums, actually we'll never finish because it's like quite huge, because the idea of using a new spectrum that we need clean spectrums that we can provide more bandwidth. By providing more bandwidth, we can provide more capacity and better throughput. For example, let's say if in 24 gigahertz, you can provide bandwidth is up to 100 meg, which is impossible to provide it in lower bands. Even like with all the ideas came like in 4G, like carrier aggregation or other things in order to increase the bands and to like improve the services and improve the throughput for 4G network, it was still really difficult. And it never reached actually 100 megahertz as a bandwidth. So like going up in a frequency will help us to use more bandwidth and more spectrum, which guarantee that we can even like have a better throughput. Now, so let's talk about security concerns actually, because this is now an active domain. Like you hear like a lot cybersecurity, security problems, privacy issues. And with all of these devices like coming online, connecting to the internet, that means we have much more hackers and we have more security threats. So from now on, the security, it's becoming, let's say, a challenge for any data-driven technology. Let's say the 5G as a network is like same as the 4G. They are using authentication key agreement. And this like system is usually designed to establish a trust between networks. And it will help even like to track the people as well. Even nowadays, even not nowadays, from the 2G days, even like you can eavesdrop, let's say, the live phone calls if you want actually. Like in the core side, you have the MSC, you like media gateways, you can there even like listen to the live calls. Like so, security breaches are always there. And so we need like a huge data, let's say, speeds nowadays, and as well like there are different solutions start coming. So initially, the RAN network was, as we've seen, like if we go say up, it was here we see like node B, RNC, node Bs. Now with the 4G and 4G advanced, RAN was introduced back in 2016, 2017, and it's what's followed now even in 5G. And it was initially called virtual RAN or VRAN for 4G, then CRAN for 5G. And actually I worked on one of these networks in Japan. It was the first network worldwide, like in 2019. Which like follow this new standard, which is VRAN standard. So now with this like cloud-based virtualization services becoming more like into these networks like 4G advanced and 5G network, now this like be introduce new security challenges. For example, like how we can protect the user data, how we can protect let's say, the user privacy. So the security nowadays is becoming even like harder, and that will require the operators or the telecommunication providers or service providers to upgrade all their IT servers and connectivity infrastructure, and they have to make sure that they can provide high quality as well as, because let's say that I provide you good service, but with a huge amount of money, for sure you'll not have a lot of subscribers. So they have to like concentrate about how we can like build quality network, reliable at the same time, and affordable to the people. And since like it's becoming, let's say, more and more, we'll move to the next point, which is the cost. So originally building a network by itself, it cost, let's say, $millions or even $billions. For example, if you go back 1 month ago, you'll read that Verizon signed a $6.6 billion to roll out a 5G network in the US. So this is like telling you how much it costs to build a network. The cost, let's say, is like, let's say, skyrocketing, it's like billions of dollars. And for sure, like the 5G will provide a lot of, let's say, increase in speed and bandwidth over the 4G network. But we have as well like to keep in mind that with the cost of the 5G deployment and rolling out the network, we still have as well another cost, like maintaining the current network, 4G, 3G, and 2G network. So the cost is increasing in the service provider. And for sure, they will be like doing their best, like for example, to at least to offer some bundles or data bundles like for the users for some short time, maybe for free or for like small amount of time, for small amount of money, but for sure this will be increasing. And for sure, let's say about the cost, let's say in 4G, we were using something called MIMO. And in 5G, we're using something called massive MIMO. And in 3G, we're not using, like it was some introduction for MIMO, but it was not that much. So the cost even of building base stations or E-Node Bs or Node Bs, like now with 5G, it's called the G-Node Bs, it's becoming more and more expensive. So instead of putting, let's say, 8 antennas, they are putting 64 antennas and 128 antennas in one place. So even the cost of building these base stations in order to provide good users, good service for the users, and to provide more capacity and accepting more users, like so the base station can handle much more users, it's really, really hard. It's not easy, and it's costing a lot of money for both the vendors who's building it and the service providers who are like buying it. So we're just talking about the RAN, so as well as in the core, as we mentioned, for the security breaches and like upgrading the IT infrastructure, and this will as well like cost a lot of money as well. You need as well to make sure nowadays like how you can interface with other networks, for example, like Wi-Fi routers, modems, stuff like that. So as well as these things will increase the cost of the network. So if you check now in the market as well, you will not find too many 5G enabled, let's say, phone. It's still like it needs some time for, let's say, the 5G phone to start coming out. And this like during this time, for sure, like all these data will be going mostly on the 4G network, which is our topic, like the 4G, like why still we need this 4G optimization and 4G network, because it's really important, because for the next 4 or 5 years, you still like consider the 5G network new and not yet mature. So the 4G will be acting first as the initial layer for all data services. Then after that, the 5G will be the main layer, and the 4G will be the backup. So such things like 4G optimization or 4G network optimization will be there for the next 10 or 15. As well as when we like, now they are researching how to build, let's say, 5G voice calls will be like based on the VoLTE standard, which is already there like in the 4G. So let's say we talked about the first 5, let's say briefly about the mobile phone challenges. So if we think about the mobile phone nowadays, so imagine like back in the day, let's say when you have only 2G, you need to support, let's say, 1 frequency band. Then with 3G, you need to support, let's say, 3-4 frequency bands. But now with the 5G, you need to support many frequency bands. So what's happening actually here? This actually, let's say, supporting these many bands will make it very hard for the mobile phone or smartphone manufacturers like to implement, let's say, a proper let's say handset, or I will not say it will be very tough actually, because let's say to build this transceivers unit to work in different frequencies, to have many, like let's say many chips from Qualcomm maybe inside. It's really hard. It's no longer easy actually. And as we can see lately as well, like the growth on the data traffic, mainly video traffic, it's really like it's too much, and it's maybe more than the half of the mobile data nowadays. It's for video traffic, and in order like to overcome that, for sure, like there are a lot of let's say to overcome this traffic volume, there are a lot of techniques. I'll just mention like briefly some of it here. Like for example, on 4G, something called carrier aggregation was introduced, and it still will be there with 5G. Higher order modulation, for example, instead of supporting let's say BBSK before, we are supporting 16 QAM, 64 QAM, up to till 256 QAM nowadays. MIMO antennas and smartphone, till now they are supporting up to 4 antennas. It's really hard to go further than that, but maybe with, let's say, the millimeter wave band, the smartphones, they can support much more antennas, because you need like less space in order to build antennas and higher bands. But still, they like for the higher bands, they're like it's an active research area, and there are a lot of issues in the millimeter wave bands. So still, like it needs many years to be, like say, a mature spectrum. Let's say as well the power management in the mobile phone. For example, imagine that your mobile phone needs to support several antennas and several, let's say, transceivers, complex transceivers. All of this, like let's say, will maximize like the consumption of your battery. Like the battery will be consuming, let's say, a lot of power. In order like to build as well as proper mobile phones which last more, you can't always keep increasing the battery size, because that means you'll be like increasing the size of the mobile phone, and it will become like too much huge, like an iPad or something. It's not, let's say, a handheld device anymore. So there are like a lot of researches as well done and optimizing this battery, and how like new technologies in battery can help, let's say, the mobile phones survive longer with, let's say, shorter charging times. As we said, like I'll just like talk a bit about the carrier aggregation and, let's say, MIMO. The carrier aggregation, the idea of it when it was introduced with 4G, that how we can increase throughput. We stuck that okay, we have a 20 megahertz band, so we have a limitation for the traffic. We can't, like, we have limitation for throughput. We can't go further than that. So the idea was to increase the bandwidth, and we will be able after that to, let's say, support higher throughput. And this will be clear, like if anyone from the telecom domain who knows like theorem or Shannon theorem, that the bandwidth is there in that equation. So when increasing the bandwidth, you'll be increasing the throughput. So the idea was carrier aggregation, that we combine more than one carrier together in order to provide a higher data rate or higher throughput, as well as, let's say, the MIMO, like introduce something called, let's say, diversity or spatial multiplexing, or let's say beamforming. All of this like aim, to provide the user with a better throughput and a better, let's say, signal and a better coverage. So several of these technologies, when you, let's say, put it inside a smartphone, it will really make it very, very hard to design, and it's to be like really complicated, especially that with the cameras that you need to be added as well. And one more thing, like if you ever work in this mobile phone stuff, like it's really hard, because usually the marketing team are the one who like give you like the design of the phone, how it should look, and they will give you like small space where you can, let's say, put the antennas. So sometimes it's really hard actually, even like to design it, because sometimes it's very hard, let's say, to get the best performance. That's the idea, because they just like the marketing team, they want just like the phone to look nice or something like that for the users, more or less. So as well as this will make very hard for, let's say, the smartphone manufacturers, and how to choose their antenna architecture, how many bands they have to include, what kind of filters they will be using, a lot of things actually. And for sure with like higher frequencies, like higher order modulation, all of this will make it way, way hard as well, as we said before as well, for the battery stuff. It will make it really, really hard to manufacture proper for nowadays. But maybe like you can see lately as well how, let's say, the Chinese manufacturers are really like, let's say, responsible for driving, let's say, the rapid growth in the mid-tier smartphones. They are really actually like ruling the market. Let's say Huawei or Vivo or Xiaomi. They are like providing actually good phones with, let's say, compared to other competitors, it's way cheaper actually. But at the end, actually, they are suffering as well with the bands they are supporting. Sometimes they have like, this is only for China, this is only for Indian market, this is international. So as well as like, this is give you like a small thing to think about, like how hard it is like to cover all these bands. I don't want to spend like more time here on the challenges actually, because we can like spend 3 hours talking about the challenges, because it's one lead to another, and it's like really lengthy talk, and some people will spend like days and in conferences talking about only these challenges. So I'll just now like move to the, let's say, I'll just mention the vendors and the service providers that you currently like see, like which companies that as a 4G optimizer you can be part of, or which companies you can work. I guess everyone knows Ericsson, Nokia, Huawei, but as well as there are like NEC, the Japanese one, Altiostar, it's American, Indian company, Mavenir is the same, GMA Wireless, Fujitsu, which is the Japanese, Samsung as well, all of them like vendors, and you can find as well different vendors nowadays with the 5G and 4G advance, with the concept of the Open RAN, which will be like, because building an Open RAN based on the cloud, it's cheaper actually. A lot of vendors actually emerged. Like Altiostar, they don't have similar network architecture as Ericsson, Nokia, and Huawei. They're barely based on the CRAN or VRAN concept. Same thing for Mavenir. And Ericsson and Nokia, they support both, let's say, normal RAN network and the CRAN networks. Huawei as well, they're supporting both. NEC, Fujitsu, NEC mainly it works nowadays on CRAN actually for the 5G services. GMA Wireless as well as the CRAN. So all of these like vendors, I can say like GMA, Mavenir, Altiostar, mainly they emerged newly, and they are competing actually with the original like Nokia, Ericsson, and Huawei. Even Samsung I didn't put here, but Samsung is like really competing with these vendors nowadays, especially that they really invest a lot in the 5G standard, and they really have very good equipment, and they are they are like I can say that like they're one of the leaders in the, let's say, the 5G TDD. So this is like kind of vendors that you can work as a 4G optimizer. Like they are like here example of the service provider operators like Docomo in Japan, Rakuten Mobile in Japan as well, Orange like in many countries. You have SK Telecom, which is in Korea. It was I can say it's the leading now for the 5G traffic actually worldwide. They already like have 18 months 5G network, like they're already working there, because they are the first one to operate it beside Verizon in the US. So they were like the first two to operate 5G networks worldwide. As well as we can't forget about AT&T, which originally like comes from the Bell Labs before they like left to 4 companies. Like AT&T was there actually, it's originated from the Bell Labs. Then you have Vodafone as well, which is spread worldwide. So as a 4G optimizer, you can work with either one of the vendors up or out there, like one of these service provider, and for sure you have still many other options.